Look down at your hands. It's easy to assume that everything you see, skin, muscle, bone, is working together in perfect harmony. You feel like a single unified organism with one collective goal, keeping yourself alive. But zoom in close enough, down past the cells and into the genome itself, and that illusion shatters. At the microscopic level, your DNA is actually a highly competitive, active war zone. Biologists call the most aggressive combatants in this environment outlaw genes. These are rogue genetic elements that prioritize their own survival and replication above everything else, even if their actions actively harm the host organism they live inside. Take the D1 variant in parasitic wasps. This specific outlaw Y chromosome forces the host to produce exclusively male offspring to ensure its own spread. It completely ignores the fact that a population with 0 females will eventually go extinct. Then there is selfish DNA. Instead of competing fairly for a specific spot, it uses a lateral strategy, copying itself into unrelated empty slots. This spread functions like a genomic cancer. It contributes nothing, simply distorting the sequence and consuming resources for its own replication. If our genetic makeup is filled with extreme, self-interested outlaws fighting for dominance, a complex body like yours theoretically shouldn't exist. It should tear itself apart from the inside before it can even function. In game theory, a biological cheater, like an outlaw gene, gains a massive survival advantage when it operates within a system of cooperators. When these bad actors are rare, they easily exploit the rules and reap huge rewards. But the math catches up with them. As the cheating strategy succeeds, it naturally spreads. Eventually, the system becomes so saturated with cheaters that they begin encountering each other. At that point, the system collapses into mutual destruction. Which leaves us with a difficult paradox. If evolution is driven by these ruthlessly selfish replicators, why do genes ever bother cooperating at all? Why invest in building highly vulnerable, complex organisms? The fact that complex life exists proves there has to be an opposing force. Something powerful is operating behind the scenes, forcing these internal bad actors into submission. Genes group together to form multicellular bodies because manipulating the environment from a distance is incredibly inefficient. To survive and extract resources effectively, they need localized physical machinery built right around them. Building a massive vehicle, like an elephant, requires years of immense biological investment. And that long delay before reproduction creates a huge window of opportunity for outlaw genes to cheat and drain resources before the investment ever pays off. You can see this risk clearly in reproduction. Millions of sperm cells are intensely competing against each other inside the same body. So why don't they evolve biological weapons to kill off rival sperm and guarantee their own success? The answer lies in what evolutionary biologists call an evolutionarily stable strategy. It's the biological system's method of enforcing a strict truce among intense competitors. To stop the biological arms race, evolution strips sperm cells of their cytoplasm. It physically removes the internal factory they would need to manufacture weapons, forcing them to drop their arsenals and compete fairly in a simple race. The genome doesn't keep the peace by instilling some shared biological morality. It enforces cooperation by engineering strict physical limitations that make cheating physically impossible. But the ultimate systemic tool used to control outlaw genes is much broader. It is the rigid, absolute division between cellular growth and biological reproduction. Standard somatic growth, like a skin cell dividing to heal a scrape, is a biological dead end. If an outlaw gene cheats and replicates wildly inside a muscle cell, it achieves a temporary victory, but it dies the exact moment the host organism dies. Reproduction is a total biological reset. It forces an entire massive organism to compress its incredibly complex blueprint backward, squeezing it through the tiny bottleneck of a single cell to move to the next generation. This bottleneck acts as the ultimate filter. If an outlaw gene acts selfishly and destroys the health of the vehicle before reproduction occurs, that outlaw fails to pass through the bottleneck and is swiftly eliminated by natural selection. Reproduction serves a dual purpose. It creates offspring, but it also acts as a vital architectural choke point that physically aligns the selfish interests of every individual gene into one shared goal, keeping the vehicle alive long enough to replicate. For a long time, the traditional evolutionary perspective assumed the organism itself was the main character. We thought the entire system existed to serve the individual. Under that assumption, phenomena like junk DNA or internal genetic warfare seem like bizarre mistakes. They are entirely counterproductive when you try to understand them from the perspective of the organism's well-being. But that confusion disappears when you shift to the gene's eye view. In this framework, the organism isn't the star. The DNA molecule itself is the true, immortal protagonist of evolution. When you view life through that lens, the boundary we perceive between us and our genes completely dissolves. It is an absolute illusion. We are not harmonious, unified individuals. We are highly regulated, temporary, and entirely disposable vehicles, engineered specifically to manage and protect the ruthless selfishness of the replicators housed inside us.